Welcome. In this video, we are looking at the fundamentals of Python, the first program, second edition. This is for the book ISBN 1097813375600092. All of this material is copyrighted by Cengage. They own the rights and the book. The assumption is that you have the textbook. I'm going to be providing just video lectures on the content in the official PowerPoints. My name is Arthur Solomon, and I'm going to be working with you throughout this course. Welcome. Chapter 2 is about software development, data types, and expressions. We have 9 main objectives for this week. We're going to be describing the phases of software development: analysis, design, code, and test. We're going to be using strings for input and output. We're going to be using integers and floats for arithmetic operations. We're going to construct arithmetic expressions. We're going to initialize and use the appropriate variables. We're going to be doing import functions from the library modules. We're going to be doing some call functions with arguments and use return values appropriately. We're going to construct a simple Python program that performs input, a calculation, and an output. And lastly, we're going to use doc strings to document Python programs. So let's go ahead and jump right on in. First section is about software development. So software development is the process of planning and organizing a program. There are several approaches. One of the more common ones is the waterfall model. In the waterfall model, we do a requests or scope. We define our analysis. We do the initial design, implementation, integration, and maintenance, and then repeat if necessary. Modern day software development is about using incremental and initiative based analysis. The analysis and the design may produce a prototype of a system for coding, and then back up earlier phases to fill in more of the details after some testing. Again, incremental meaning we do smaller milestones, and each milestones actually help build up the program. And here is our initial request. We do our scope, we do our analysis, we do our design, our implementation, our integration, our maintenance, and then we actually verify all of these steps and repeat if necessary. The interesting thing here is our last phase is our maintenance, and the cost of correcting a fault is the greatest if we are dealing with our last phase. So programmers rarely work as they hope, so we have to keep that in mind. We must perform extensive and careful testing to ensure that our program is actually doing what we expect it to be doing. The cost of developing software is not spread over equally. Normally, maintenance is the more expensive of the costs. So next, let's move into our strings, assignments, and comments. We're going to be using text processing as by far one of the more common applications of computing. So we're going to be looking at how to do text processing. For example, emails, text messaging, web pages, word processing, Word, Excel, all rely on manipulation of data, normally consisting of strings of characters. I said Excel. Excel can be strings of characters, not necessarily actual numeric values. However, it can also be both, so we have to be careful with that. So data types. A data type consists of a set of value and set of operations that can be performed on those values. A literal is the way a value of the data looks to a programmer. Ints and floats, for example, are numeric data types. They represent numbers. For example, an integer is normally a whole number. A float, a real number, for example, are floats. They can be decimals, they can be whole numbers, they can be any combination. A string, a character string, is a character that is a string of characters. It can be letters, it can be numbers. If it's a number, it's going to be treated as a character string, not the number 66, but the type character 66. So there is a difference between the two. What's interesting is in Python, a string is literally a sequence of characters enclosed by a single or double quotation marks. So here we have and. However, you'll notice that we have an additional set of quotation marks. This represents empty string. Double quote strings are handy for composing strings that contain single quotes. For example, if you need to actually do I am or I'm, well, that single quote makes it a little bit harder. If you're doing double quotes, it makes it a little bit easier to be able to print out those strings. When you use double quote, single quote, and double quote, double quote, double quote for multiple line paragraphs, it makes it a little bit easier. This is a very long sentence that will extend all the way to the next line because of the way the quotes are. When you evaluate a string in Python without the print function, you can see the literal for the new line characters. /n will embed in this result. So if you want to do this is a very long sentence, extend /n all the way to the next line, that /n will actually show as a embedded in text command. Some in-text commands are things like /b, backspace, /n, new line, /t, horizontal tab, // is a slash character, single quote is a single quote mark, /double quote is the double quote mark. So here we can show that we are joining strings, combination of high quotes plus quote there quote plus kin. We can now combine them. We can also do things like addition as well. When we're doing the star operator, allows us to build a string by representing another string and a given number of times. So we can actually do certain algorithms that have both integer numbers and strings, which we're going to show a separate video on that, but you can increase how many times a printout is done by adding certain numerical values. So a variable is an associate with a name with a value. It allows it a little bit allows it a little bit easier to make sense of what we're trying to do. For example, when we want to temporarily hold a value of month, for example, well, we would define a variable month, that's what we would call it, and that would temporarily hold the value if we have an input that says what is the month today, and we could store it using variables. There are some naming concerns when we name our variables. For example, there are reserved words you cannot be used as a variable, like you can't use if or def or import. And there actually is a longer list as well. The name must begin with a letter or an underscore. The name can contain any number of letters, digits, or underscore, but no special characters. Names are case sensitive. Weight capital versus weight lowercase are different. Normally, beginning each word in the variable name with an uppercase except the first one. The example they use is interest rate. I actually like to do something slightly different. I will do like an int underscore and a variable. So it just kind of depends on who the programmer is when they are declaring their variables. Programmers use all uppercase levels for symbolic constraints. For example, like tax rates or standard deductions. Variables receive the initial values and can be reset to the new values with an assignment statement. That will normally be variable name equals some form of expression. Subsequent uses of the variable name and expressions are known as variable references. So here we can have variable first name, variable second name, and then we can have a new variable, which is full name, which is the variable first name plus the variable second name, and that way we can now print out our full name. That's how we can use variables in a very simplistic manner. Normally, variables serve two main purposes: help the programmer keep track of data over time. Second, they allow programmers to refer to complex pieces of information with a simple name called an abstract. As we're doing this, we also need to leave comments. We need to be able to comment our program so that we understand what it is the program is trying to do. So normally a piece of program text that can contain certain characters that the computer will ignore that provides useful documentation. A docstring, for example, is a multi-line string of the form example. That way the computer will actually read it and ignore it, but it allows the program writer to at least refresh what that code or what that script is doing based off of the comments. We have an end-of-line comment. Basically, if we begin the symbol $sign and extend it to the end of the line, might explain the purpose of a variable or strategies used by a piece of code. For example, here we have a rate. We define our variable. What does that mean? We could do the pound, and the rest of that line is actually going to be ignored. That comment is made for us, the programmers. So tips to relate comments and docstrings: begin a program with a statement of the purpose, accompany variables with definitions and comments, precede major segments of code with a comment, include comments to explain the more complex portions of your code. Commenting is more than acceptable. Comment happy is even better. Comment everything so that at a quick reference or a quick glance, you can understand what your code was originally doing. The first application of a computer were to crunch numbers. The use of numbers in many applications is still extremely important. So that means we have to understand the numeric data types and data sets so that we can understand how to engage. Integers are, again, infinite numbers, whole numbers, and in Python, int can range from -22 to the power of 31 to 2 to the power of 31 minus 1. They can be large. A computer's memory place limit on the magnitude of the highest positive number and the lowest negative number, and that's that typical range. Integers literally are written without commas. They're whole numbers. A real number is an infinite precise number or precision number. The digits in the fraction part continuing forever. For example, a floating point can represent real numbers, and they can be between -10 to the power of 308 to +10 power 308. Typically, a precision is 16 digits. That means you can actually list pi to 16 digits. Here's some examples of our decimal notation or scientific notation. We can do decimal notation, we can do scientific notation, and we can also provide their meanings. Just kind of depends on what we're trying to accomplish. So in Python, characters literally look like a string, literally, and are the string type that they belong to. For example, if we're doing different character sets and ASCII sets, we can actually map certain ordinal and character functions and convert those characters to and from our ASCII. If we do ORD A, we get the appropriate ASCII feedback. If we do ORD capital A, we again get the appropriate feedback. If we do a character and we do 65, we get the appropriate ASCII character that's 65. So knowing the ASCII keys are helpful for certain things. Expressions are the next area, and they are literally evaluates to itself. A variable reference evaluates the variable's current value. So expressions provide easy ways to perform operations on data values to produce other values. So when you enter a Python shell prompt, an expression operands and are evaluated. Its operator is then applied to these values to compute the value of the expression. We've already seen several of the arithmetic expressions. negative exponents, multiplication, division, quotients, remainders or modulus, addition, subtraction, and so forth. The preceding rules basically apply. Parentheses, exponents. Notation is evaluated next. Basically, if we're doing this, we're doing the rules of operations. Parentheses, exponents, multiplication, division, addition, subtraction, and we do the left associate order. We do it left to right based off of our rules of order of operations. You can use parentheses to change the order of evaluation as well, because it does parentheses first. So when both operands and expressions are on the same numeric type, their resulting values is also expressed in that type. For example, 3 divided by 4 is 0, whereas 3 divided by 4.0 is 0.75. Integers versus floats. For multiple line expressions, we can use a /, and that will allow us to use multiple lines. So our mixed mode arithmetic involves integers and float numbers. With this example, we must use a type conversion function when working with input of numbers. Its function with the same name as the data type to which it's converted. Basically, the input function returns a string as its value. You must use either int or float functions to convert the string to a number before performing arithmetic values. For example, enter a string or text. If it's a string that contains numbers, we will actually create the appropriate integer. Again, integer will take the whole number. If it's dotted decimal, dotted decimals aren't really whole numbers, they are floats, they are precision numbers. Strings are going to actually be values of character strings. They are different than a numeric value. So if we note that the int function will convert a float to an int, and it will not round. So int 6.75 will produce 6. If we want it to round, we could do round 6.75, and it will create that to an integer that rounds to the nearest whole number. That's a built-in function that we are just supposed to know about. There are several built-in functions that we have not discussed that we will be looking at later in our book. So type conversions also occur in constructions of strings and numbers. Profit, for example, you can include a print with a character $, plus profit. You can also do things like traceback, and the traceback will be a file standard in line 1 and then in the module, though this will actually give us an error because we need to be able to list the string, because here we're going to be treating it as profit as a string, not a numeric value. Python is a strongly typed program language, so we have to be careful with some of our syntax. If we are treating our characters like strings and we actually have them as integers, they don't like that. So we have to pay attention to the character types and the data types that we are working with. Mixed mode arithmetic and type conversions are important. Python will include many useful functions which are organized in libraries of code called different modules. These modules actually are listed on Python's main website, so you can get a complete list of what those modules are, even though right now it's outside the scope of what we are doing. A module basically is a function, and a function is a chunk of code that can be called by the name to perform a task. A function can also require an argument or a parameter. The arguments may be either optional or should be required. When a function completes its task, it may return a value back to the original program as part of the program that called it. May not be, just kind of depends. So for example, we can learn how to use a function argument by using the help function. If we are at a terminal, we type help, and we can actually include a module name, and it will actually produce the help for that module. Here we're using help round. Round is the name of the argument that we are passing to the help function. Round is also a function that has a specific definition for it. Help is just letting us discern what it means. There are math modules like abs and round. The math modules include functions that perform basic arithmetic. They use resources from a module to write the names of a module as a qualifier, followed by a dot typically. So like math.pi, math.square, math.square root, and so forth. You can avoid the use of these qualifiers with each reference by importing the individual resources if necessary. For example, you can, from the import command, do an import pi and import square root. That way you can just use pi and square root as opposed to having to do math.pi and math.square root. You can do the import of all the modules by doing a simple from statement, from math import star. The star says import everything. So in our main module, basically we can do a case study. Earlier in the chapter we showed how to write a documentation of a Python script. Here we can do a differential in the script from other modules in a program. We can call it main module. Like any module, the main module can be imported. So we can import tax form, for example, and then from there we can define certain inputs. Input the gross income, input the number of dependents, and it can do simple things like calculate income tax. We could do the help command to see the structure of our function tax form. So what we do is we start with a comment with the author's name, the purpose, and any other relevant information in a doc string. Then include in the statement kind of import into the modules, initializing important variables, and that are sustainable commented, prompt the user for the input, save the input in a variable, process the input, produce the results, display the results, and then comment them appropriately. So how do you run a program? How do you run a script? A way to run a script in Python is to actually open a terminal window, click the type here and search box, type the command, and click the command prompt in the window. Navigate or change directory prompts so you can see the directory that contains the appropriate script, and then run the script by typing python 3 plus the script name.py. That's how you would navigate to the script and run it. And again, this is at a terminal window, so any terminal emulator should be able to do this. So a command shell or Windows command line, those are terminal windows. Here's an example. Here's another example, running a Python script in a terminal window. So Python installation enables you to launch Python scripts by double-clicking the file also. Again, you may require the .py file to be set to open by Python, and these are typically called flyby window problems. Basically, the windows will open, run, and close automatically. The problem is, we can add an input statement at the end of a script that will pause until the user presses the enter key. Basically, no longer allowing the script to run without having an input at the end, so the window won't close until the user has some type of input. And that is this chapter in a nutshell. We covered things like the different types of modes for defining our methodology, looking at literals and data values, looking at strings, looking at character naming, looking at the different types of character types, looking at doc strings, looking at commenting, looking at some data type like integers and floats and operations, and understanding mixed mode. Lastly, we looked at function calls and how to import function calls. So that's all I had. If you have any questions, please feel free to reach out. Thank you. So as we finish up, if there are any questions or concerns, please feel free to reach out. Again, some of this content may be new to you, so instead of struggling, ask questions. Remember, as you ask questions, it also helps with data retention and information retention, so engage. If I can do anything to help, let me know. Thank you.